Okay, we are going to do the second video on vectors. This video addresses how to convert a vector when you know the magnitude and direction to component form, and it also addresses an application problem. So the application problem we have is here. It's from your textbook 695 if you want to follow along. A plane is flying at 675 miles per hour in a course that's 75 degrees east of north. It is helped along by a fierce wind blowing at 140 miles per hour in the direction of 32 degrees east of north. If the plane flies for 2 hours, what are its true speed and direction, and how far will it be from its starting point? So we know the wind is going to knock the plane off course a little bit. The question is, how far off course is it going to set it? Our first step is to draw a vector diagram to represent this situation. So what we're going to do is we're going to consider the two vectors somewhat separately. So we have our first vector. Let's do one representing the plane. So the plane is traveling 675 miles per hour on a course that's 75 degrees east of north. Here's north, here's east. 75 degrees is almost down to the bottom. So we're going to have a plane that's traveling like this. And that's 675 miles per hour. Now this angle measure here is 75 degrees, which means the angle up here is 15 degrees. Okay, so that's our first vector, that purple one. Let's do the wind in green. And we know this information about the wind vector. We have the wind, just to anchor it here, we have the wind blowing at 140 miles per hour in the direction of 32 degrees east of north. So if I'm going 32 degrees, that's only a third of the way. So this vector is going to have a different direction, and it's going to be shorter. So if we draw a vector kind of like this, the length of it is 140. The angle in here is 32 degrees, which means this angle would be 58 degrees. Now that's lovely. It gives us two separate vectors, but what we want to consider is how they affect each other. And so if we were to take this wind vector and start it from the end of the plane vector, we'd see it would go up a little bit like that. And what that does is it causes the plane to go that far off course. So if the plane was flying in these conditions, it would actually take a course that would look something like this in 1 hour. So the question is, how do we figure out what that course is? Well, this is vector addition. We'd be adding the purple vector to the green vector to get the red vector. And to do vector addition, we need component form. So let's start with the purple vector first, the plane. We have a hypotenuse of 675, and we have, I really didn't draw that correctly. Let's do it more like this. 675, and we have this angle here, which is 15 degrees. And basically what we want to calculate are the x and y values that make up the sides of that right triangle, because we know it's a right triangle. And in order to get that, we can use right triangle trig. So we know this angle right here. We know that the x side is the side that's adjacent to it. The y side is the side that's opposite, and the 675 is the hypotenuse. So let's start with x. To get the x side, it would be adjacent over hypotenuse. So that is cosine of 15 degrees equals x over 675. And to solve that, we would take 675 times the cosine of 15. And then let's talk about the the y value, which is opposite over hypotenuse, which is sine. So the sine of 15 degrees is also equal to y over 675, which we can write as 675 times the sine of 15. And when we calculate those, let's see what we get. 675 times the cosine of 15 is 651.9999, so we can say 652.00. And then 675 times the sine of 15 is equal to 174.70. Now, because of the directions this is going, it's in the first quadrant, so that means both the x value and the y value are positive. The same is going to be true for our wind vector, also in quadrant 1. So if we sketch that one, we have a hypotenuse of 140 and an angle of 58 degrees. And also a right triangle. And we're also trying to find an x value and a y value. So we're going to use the same exact method, just a different angle measure. Instead of using 15 degrees and 675 as the hypotenuse, we're going to use 58 degrees and 140 as the hypotenuse. So to write the cosine, that would be, or to write the x value, that would be cosine because it's the adjacent angle. So cosine of 58 is equal to x over 140, which is written as 140 times the cosine of 58. And to find the y length, we're talking about the opposite side, which is sine is equal to y over 140. And so then to write that, we're going to take 140 times the sine of 58. And when we calculate those, 140 times the cosine of 58, we get 74.19. And 140 times the sine of 58, and we get 118.73. Okay, so our goal is to add these together. So to find the red component form, we're going to add the two x values together, and then we're going to add the two y values together. So I'll do that quickly here. 652 plus 74.19 equals 726.19. And then our y values are 174.70 plus 118.73. And that value is 293.43. So that means the red path, or the path of the plane, is going to go, in component form, going to be going 726.19 miles east and 293.43 miles north in 1 hour. That's where it will be. But what we want to find is the actual distance it's traveled, because it's not traveling the path of the triangle, it's traveling the path of the hypotenuse. So we did this in the first video, but we basically just need to use the Pythagorean theorem to find our hypotenuse out here. And that will tell us the speed of the plane. So let's do that. 86,101 is 293 squared. 726.19 squared is equal to 527,351. We're going to take the square root of those added together. So, square root of 527,351 plus 86,101 is equal to, that is not right. That's what I get for using my phone as a calculator. I'm going to try this again. That's much better. So the answer I got is 783.23 miles per hour, which makes sense because we had decided it was going to be traveling further because of the wind. So this is our speed per hour. And then to figure out the direction, we just need to know this angle, and we can use inverse tangent to do that. So the inverse tangent of the opposite side over the adjacent side will give us the angle. And I get an angle of 22 degrees, which also makes sense because we know it's going to be going a little higher than it originally intended. It was originally 15 degrees. Now it's going to be 22 degrees. And then the final question that this word problem asked was, if the plane flies for 2 hours, what would the resulting speed and direction be? And so, whoops, going the wrong way here. You can essentially double the miles per hour. So if 783 is 1 hour, we're going to multiply that by 2. And the angle is not going to change because it's going to keep going at the same angle. Hope this was helpful.